Hello, good afternoon, everyone. Welcome to this ETSI webinar. I'm Nathalie Guinet from the ETSI events team, and I'm pleased to welcome you today to this webinar for this new software development group called Open Operator Platform, OpenOP, and they will be presenting their first release of their software development group today. For your information, we plan to go for 75 minutes. You can type in questions in the question box of the BrightTalk platform. And the webinar is recorded, and you can also, therefore, access it and the presentation in PDF after the webinar. So let me now present to you our panelists. So we have Vasilieros Theodorou, who is the SDG chair. Hello. Dimitrios Gogos, who's the TSC chair. Panastasios Pandis, who is SDG OOP developer. Konstantinos Chartias, who is the AI and module leader. Sergio Jimenez, who is the federal manager, module leader. And Gerald Kingston, who is the research engineer. So let's go into the technical part now, and I'm handing over to Vasilios. Enjoy the webinar.
So, hello everyone. I'm Vasilios Theodorou, and I'm the Head of Research Collaboration at Intracom Telecom, which is a global telecom systems and solutions provider. It's headquartered in Greece, but it has international operations worldwide. So today I will wear the hat of the SDG OpenOP chair, and I will introduce the Open Operator Platform initiative that has recently launched relatively as an ETSI SDG. So first of all, I will start by introducing briefly what an ETSI SDG means. This is a relatively new initiative that is brought by ETSI about creating open source projects in the direction of bringing together different communities, the communities of standards, the communities of open source, and the communities of research. And in this way, to catalyze innovation, to enable rapid prototyping, experimentation, and testing with new standards, with new technologies, with new use cases, and essentially to increase and accelerate adoption across different ecosystems and communities and domains. So OpenOP is actually one of the new SDGs by ETSI. There are several more, and feel free to find some more info on the website that is presented here. A little bit about OpenOP background. So it all started with a core group of researchers, and both from companies, larger or smaller ones, and research organizations, but with a very large footprint in collaborative EU projects, and in particular within the SNSJU work program that is working on the next frontier of telecom, and in particular 6G projects. So in various projects, what we noticed was that there was an obvious convergence between connectivity, cloud, AI, and data domains within the realm of the cloud-native cognitive continuum, or edge cloud continuum, or telco cloud, as you might have heard. And you know, this whole concept is to integrate heterogeneous distributed technologies and devices, but also different administrative domains. At the same time, we saw that there was a high degree of fragmentation across different stakeholders in this ecosystem. So we identified the need to easily onboard vertical and application-oriented users so as to enable and foster innovation in new verticals, like, for instance, automotive, industrial IT, smart cities, health, etc. And in particular, we face the need to federate multiple beyond 5G and 6G testbeds in the flagship StreamC SNS project that is called Sunrise 6G. And naturally, we came across many different standards and industry-driven or open source initiatives that were relevant, but nevertheless, there was no practical implementation that we could already use. So that's where we decided to pursue an open source operator platform for the telco cloud with the valuable hosting by ETSI in order both to maximize our reach, but also our value and usefulness to broader audiences. So OpenOP is an open source unified framework for operators, developers, and service providers and aggregators to enable interoperator network and beyond 5G and 6G testbed federation. Is also aligned with GSMA requirements for the East-West bound federation. And at the same time, it supports the northbound developer-friendly APIs, and in particular, Linux Foundation CAMARA APIs. And at the same time, on its southbound, it supports the integration of a large set of technologies, both cloud native, cloud edge, and network, including Kubernetes, 3GPP NEF, ETSI MEC, and Vimano, etc. And also using standards for the management of mobile, AI, machine learning, and data capabilities and services. So in essence, this platform facilitates a neutral and welcoming environment for researchers, SMEs, operators, vendors, to jointly co-develop, co-experiment, and co-validate new capabilities while following up with the next generation of innovations in the telco domain as they unfold. We started recently in July 2025. That was when our kickoff was in Turin, in Italy. And up to now, there has been a lot going on. We have had 2 releases. My colleague Dimitris Gogos will tell you more about it. We have presented OpenOP in various different key venues. Also due to the synergies and essential collaboration with large R&D projects, we have been recognized already by the SNSJU, which is the funding framework of the European Commission for 6G research, as one of its top 10 key achievements for 2025. And we have, of course, participated in the co-organization of several events, as well as including the premier EU event by ETSI, which was in Sofia Antipolis a couple of months ago. What is interesting to notice is that we have grown from 8 founding members back in July to currently more than 25 members and participants, and we are growing. So our prestigious, let's say, members and participants include GSMA, large major telco operators like Orange, BT, OTE from Greece, PT Portugal, but also research institutions that are key for the next generation innovations in telco service and telco technologies like EURECOM, Fraunhofer Focus, etc. So what I would like to stress is that OpenOP is planning to be synergistic and complementary in nature with different projects and other initiatives. So we don't plan to reinvent the wheel, but instead we plan to leverage and complement existing standards, technologies, and projects and groups within the family of ETSI, but also with other groups. We have already established strong synergies with flagship research projects like Sunrise 6G and 6G DALI that I have the pleasure of technically managing, and others. And, as a testimony of our growth phase, here is just a snapshot of our currently 27 members and participants. Maybe they have already grown since the time I prepared this presentation. And we have had recently, early March, our first release, which was a robust version of the main functionalities that OpenOP supports. Also, realized by the different modules that are listed here, each of which is responsible for either interfacing with our developers and the northbound interface, or being the brain and the orchestrator of services and application services towards different versatile technologies, or federation, east-west bound, but also the newest modules, which are mostly on AI and data layers, and we're very, very proud of them, allowing super usability combined with our portal. More on that from my colleague on the next presentation. So thank you very much.
Thank you, Vasilis. Hello, everyone. My name is Dimitris Gogos. I'm from Intercom Telecom, and I'm the chair of the Technical Steering Committee at OpenOP. You just heard the story about why OpenOP exists and how we've came so far. So I would like to go one level deeper and show you how the platform is built and what Release 1 delivers, and how you can get started with OpenOP. So let's have a quick look at the OpenOP architecture as it stands today. At the very top, you have the consumer, who could be an application provider, an enterprise customer, or any other vertical, and it has three ways to interact with the platform. The first one is via our CAMARA APIs, the second one is via our developer portal, and the third one is via our AI Squared module. Inside the platform, we have four core components: the Open Exposure Gateway, which is the brains. This is the front door, the Service Resource Manager, which is the brain of the platform, the transformation functions, which talk with the infrastructure on the southbound, and the Federation Manager, which talks with the Federation managers of other partner OpenOPs via the GSMA east-west-bound interface. So now let's see how these components work together by following a request end-to-end throughout the platform. Imagine a developer who already registered their cloud gaming application within their platform, and he's now ready to deploy it at an edge location close to their user. The developer will make a single CAMARA REST API call saying deploy this application to this edge zone. The request will hit our Open Exposure Gateway, where we validate the request and we apply different security policies, and then forward it to the next component, which is the Service Resource Manager. The Service Resource Manager is the component that understands how this request maps to specific services and resources. And it looks at the target zone, it picks the correct adapter based on the infrastructure that runs there, for example, a Kubernetes cluster, and then goes on into orchestrating the deployment. To do so, it uses the transformation functions, which in our platforms are implemented through our TF SDK. And this is what turns the technology-agnostic request to technology-specific actions. And in this case, it translates to Kubernetes API calls to create the different resources like pods, deployment, services, etc. The result, which is the application being deployed at the edge, goes back to the developer who did the original request. What is important here is that the developer's experience stays the same regardless of what runs underneath. So the same CAMARA API call works if in the edge zone we have Kubernetes or any other supported platform by OpenOP. And all the infrastructure-specific work happens inside the platform, and it's hidden from the developer. Of course, the same architectural pattern applies for our other capabilities, like network capabilities over different vendors. And for example, we have the QD session management and the device location retrieval, which will also we will showcase this in the webinar today. Now, let's touch briefly upon the federation. I will keep this short as we have a dedicated session on the topic, so I will just give an overview. Imagine the same developer, but this time the best edge zone for his user base is not in the infrastructure of his local operator, but on the infrastructure of a partner operator. The developer will make the same CAMARA API request, but this time he will select a remote edge zone. The request reaches the Open Exposure Gateway and then gets forwarded to the Federation Manager, who will talk with the Federation Manager of the partner OpenOP via the GSMA east-west-bound interface. Then in the partner OpenOP, the deployment will start using the dedicated transformation functions over the infrastructure of the partner operator, and the result will flow back to the developer. This is quite powerful as the same CAMARA API call works across operator boundaries without the developer having to integrate separately with a partner operator. Sergio, who is the module leader of the Federation Manager, will go through all this in a demo later today. Okay, so that is what happens inside the platform. Now let's see how you could reach it from the outside. Release 1 gives you 3 ways to interact with the platform. The first one is our developer portal. This is an intuitive web UI built with Next.js and TypeScript, where developers can log in. They can browse our different capabilities. They can register the applications, see the available zones, and then eventually deploy their applications using the browser. The second way is directly via the API of the Open Exposure Gateway. This is more meant for developers who write code or for systems that want to integrate with OpenOP externally on the northbound. And in release 1, we support CAMARA APIs like the ETSI application management, the quality on demand, and the device location retrieval. The third way to interact, and it's an important addition, is the AI squared module. And here we expose an MCP server and an AI agent that allows developers to interact with the platform using natural language. So a developer could write a prompt in plain English saying, create a low latency QoS session for this device. And then the AI agent will pick the relevant CAMARA APIs and go on into fulfilling this intent. By doing this, we're lowering the barrier for developers who are not telecom experts, but want to use the different network capabilities of the operators and the underlying infrastructure. Kostas Hartsias, who is the module leader of AI Squared, will be talking more on this in a few meetings. Okay, so let's see now what we have delivered concretely in Release 1. Release 1 is an early milestone for OpenOP, and it's mainly intended for experimentation, integration testing, and getting feedback from the community. So we have delivered the 4 core platform components that I talked about: the Open Exposure Gateway, the Service Resource Manager, the TF SDK library, and the Federation Manager. On the developer access layer, we have the developer portal, which is an intuitive GUI that developers can use to browse the different capabilities, and the AI squared module, which allows the MCP-based AI interaction with the platform. And on the aspects of integration and deployment, we have a validated integration of OpenOP with the Open Exposure NEF by EURECOM, mainly around the scenarios of QoD session management and device location retrieval. And we have also created Helm charts and deployment scripts that allow developers to get started with the platform quite quickly. Now, looking ahead to Release 2, the roadmap is still under definition, but we can give you a sneak peek on that. Release 2 is building on top of the foundation that Release 1 provides, and we are trying to make the platform more robust and easier to use. So we are working on platform hardening, where we are refining the architecture of the different module boundaries and how they communicate with each other. We are refactoring parts of our code base in order to reduce technical debt and also to make it easier for developers to contribute to the project. And we're looking deeper in the authentication and user management feature of the platform, mainly around the integration of Keycloak with the Open Exposure Gateway and the developer portal. Additionally, we are looking into bringing more capabilities and exposing more capabilities in the platform by bringing in new CAMARA APIs like the traffic influence, the SIM swap, and the number verification. Finally, an important direction that we're taking is the multi-clusters Kubernetes support, moving from a node-based zone to a cluster-based zone, which is closer to how real distributed edge environments are deployed today in practice. So if you want to try OpenOP, it really takes a single command. So on your local development environment or on your laptop, you could run our kind script that will spin up a local Kubernetes cluster and deploy all components. So within 5 minutes, you could go from zero to a running platform. Or, or if you have your own Kubernetes cluster, you can use the single Helm install command using our umbrella Helm chart and bring all the components on your cluster. Once this is up and running, then you can go to our documentation at openop.etsi.org/documentation, or visit the public ETSI GitLab to have a look at the code, or deep dive in the Get Started guide or our architecture docs on the relevant sections of the documentation. So that concludes my introduction. We are very excited about the future of OpenOP, and we would like you to invite you to join us, to contribute, give us feedback, and to help us shape the next releases. So now we'll hand over to Gerald, who will be speaking about the integration of OpenOP with the Open Exposure NEF by EURECOM. Thank you. And over to you, Gerald.
Thank you, Dimitros. Hello, everyone. My name is Gerald Kingston Yanasekaran. I'm working as a research engineer at EURECOM Sofia Antipolis. I'm mainly contributing to the Open Exposure NEF project and OpenOP. So in this presentation, I'm going to walk you through what is Open Exposure project and how it contributes to the OpenOP and how it benefits to the application developer. So let's get started. So this is my agenda today. I'll start with the introduction to Open Exposure project. Then I'll continue my introduction to Open Exposure NEF, and then we will see how to integrate the NEF with OpenOP. And then I will give you the overview of Open Exposure Core Simulator. Then I finally wrap up with the NEF deployment guide plus demo. So first, what is Open Exposure? So Open Exposure is a project which is expandable open source toolkit for network exposure and prototyping. It is mainly designed to connect applications with network capabilities while enabling rapid innovation. So this project has been released by NetSoft team at EURECOM under the Apache 2.0 license. So this release includes 3GPP network exposure function, core network simulator, and some vertical application examples for the developer to work on. So what is our mission and what value we bring to the ecosystem? First, there is still some gap between the telco world and the developer world. So we would like to bridge the gap by connecting telcos, network APIs, researchers, and application innovators to turn the network capabilities into real-world assets. Second, interoperability. So the NEF work with multiple core network. It simplifies the integrations and you can do more experimentations on it. Third is all about fast prototyping. So core networks accelerate the testing, validations, and deployment of the new service. Fourth, fueling open innovation. We would like to expand the open source ecosystem with new services, use cases, and intelligent capabilities. So let's see what is Open Exposure NEF. So NEF is an open source implementation of the 3GPP NEF from release 18. So it lets the application to consume network capabilities through the standardized 3GPP API. It abstracting the complexity of the underlying core network. It also lets the application to interact with the NEF without any dependency on vendor-specific interfaces. So this abstraction allows the application developers to be more portable on different networks and core implementation. Therefore, NEF is a key enabler for interoperable network-aware application that can safely request and influence network behavior. We successfully tested this NEF with OpenR Interface Core, Free5GC, Open5GS, and of course our own Open Exposure Core Simulator. So let's see how the NEF is actually implemented. So NEF is a collection of 3GPP API and two non-standard APIs. So the developer can make use of this API to work on the use cases. For instance, the traffic influence API is used to steer the traffic to edge locations, and monitoring event API to subscribe for UE event, a section with the QoS API to request for guarantee QoS flow, and UEID API is to resolve UE identifiers, and UE address is to look for IP addresses, analytic exposure to access network analytics and insights, and dataset exporter to export the data network for analytics and ML purpose, UE profile service for managing UE level profiles. So let's see what is OpenOP and how NEF is contributing. So we all know OpenOP exposes CAMARA API, which is designed for the application developers, and the NEF exposes 3GPP API that abstract the network capabilities and complicities of the underlying core network. By integrating the NEF with OpenOP, we bridge the developer world with the telco world. So let's see what value it's bring to the ecosystem. It simplifies the access. So the developer can consume network capabilities without needing a telco expertise. And what it does that standardized translation. So the camera intents are directly mapped to the 3GPP procedures in a well consistent and reusable way. So let me give you an overview of our open exposure core network simulator. So it simulates 3GPP control plane procedures like UE registration, PDU section creation, modification and release, mobility procedures, and dedicated QoS flow activation and deactivation. It also generates the user per plane traffic without deploying an end-to-end 5G network. It also provides a Grafana dashboard for real-time monitoring and statistics like IP address and throughput. Another important feature is realistic UE mobility. So the user movement is based on the waypoint working on real-world OpenStreetMap. So it also has automated handover support with LMF. It also has dual reporting like cell level as well as enriched uplink TDOA where you can get the geolocalization values. And the last is about the map visualization. You can see the real movement of the UE, GNodeBs, and handover. So let's see. Open Exposure 3GP NEF plus Open Exposure Core Simulator, which gives you a powerful sandbox for network API testing and integration without an end-to-end 5G core network. So this is an additional slide for you to understand in a better way. So the Open Exposure NEF works with multiple core network, as I mentioned in the aforementioned point, but not all the core network supports all the API. For example, OpenR interface core supports monitoring event UE address and UEID APIs, and Open5GS supports as section with QoS, and Free5GC support traffic influence. And of course, our Open Exposure Core Simulator supports all of the APIs. So let's see NEF plus core simulation in action. So in this demo, I'm going to show the deployment of Open Exposure NEF with Core Simulator and how to subscribe for the monitoring event. So let's start it. So first, go to your browser and search for Open Exposure project. You can find it in the EURECOM GitLab repository and go to NEF. And in the NEF repository, you can find the deployment sub-repository. So in this README, you literally have everything you need to run the NEF. So I'll let you read this README later. So clone the repository. So if you look into the repository, you can find two folders. So NEF Compose is to deploy the NEF as a standalone component to work with your core network, and NEF Core Sim Compose is to deploy the code with the core simulator. This is what we're going to do today. And of course, in each folders, you have the config file for each services. I'm not going to show you all the services. Instead, I'm going to show you the core simulator config file. So in this config file, is it worth to mention the PLMN and the number of UE, number of GNodeBs, and the latitude, longitude, and positioning method is chosen as uplink TDOA. This is what the core simulator is going to load and create an environment. So we're still using the Docker Compose to run all the containers. So I started all the containers. So you can see all the containers are started. So let me show you the logs of Core Simulator. So you see the Core Simulator passed a config file of the Core Simulator and it deployed 4 GNodeBs with other core network components like AMF and LMF. As I mentioned in the slide, we also have a graph map view. You can go to this endpoint and you can see the map view. So here you can see the map deployed with the 4 GNodeBs, and you can see the movements in the sidebar, and we also have the Grafana dashboard. If you go to this endpoint, you can see the statistics of the UE. So for no UE is connected, so that's why we are not seeing anything. To start the core simulator, there are two ways to start the core simulator, either by using the CLI or else by calling the endpoint. So here in this demo, I'm using the CLI to start the core simulator. So after starting the core simulator, you see the UE movements on the map and the location updates on the sidebar as well as on the terminal. You can see where the UE is currently located on which cell and where the UE is moving towards which direction. You see all the informations on the terminal as well as on the sidebar. So next, I'm going to show you how to subscribe to the monitoring events in the 3GPP way. So for that, you need to have the IP address. To get the IP address, go to the Grafana dashboard, refresh the page, and you'll get the IP address of the UE. Just copy down. And I'm using the Swagger UI to subscribe for the monitoring event. So I'm going to use two APIs to subscribe for the monitoring events. This UE ID API is to get the external ID of that UE, so which represent the UE in that network. So I'm placing the IP, and once I execute the API, you'll get the external ID. Copy down the external ID. We are going to use this external ID in the monitoring event subscription to get the location updates. So I copy down, and then I'm going to use this external ID in the monitoring event API. So in the external ID field, I'm going to place this. So once you execute, you will see the location updates there. I mean, the immediate response of the UE. So you can see the geographical area with latitude, longitude informations, and the position method as uplink TDOA. You have everything here. You can easily monitor. So that's all about the video, and thank you for watching. I hope you enjoyed it. So my colleague Stasios will explain the camera location API with OpenOP.
Hello everyone, I'm Anastasios and I'm a developer working on OpenOP. We are going to be deploying the OpenOperator platform on a local Kubernetes cluster through Helm charts and then connecting it to the EURECOM NEF and core simulator to showcase the functionality of the CAMARA location retrieval API. So let's start with the deployment. Okay, so we start by visiting OpenOP's GitLab pages and moving into the OOP Helm deployment directory. We copy the GitLab link from the repo and git clone it to our workspace. This folder contains a Helm chart, the kind-specific values, and the deployment scripts we are going to be using. The kind configuration defines the local cluster name, the storage mount, and the port mappings that expose the OpenOP services on localhost. So for the kind setup, the values.yaml file, it will configure the services for the node ports. It will set the ports and also provide the environmental variables needed by the OOP components. At this stage, the NEF adapter URL is still empty because we do not know the NEF ingress IP since we have yet to integrate it. Next up, we continue by running the deployment script. The script performs two main steps. First, it bootstraps the kind cluster, and then it creates the OOP cluster, prepares the namespace, creates the OOP user service account, and creates the required Kubernetes permissions. Then it runs the Helm deployment for the OpenOperator platform. In the output of the script, as you can see, we can see the port on which every service is exposed on. Once the deployment finishes, we verify that kubectl is using the correct context. Then we check the Kubernetes node. And finally, we look at whether the pods are up and running as expected in the OpenOP namespace. As you can see, all instances are up and running. OpenOP is now deployed. So here we are looking at the OEG Swagger UI. The OEG is a northbound API entry point for CAMARA API calls. You can see the different API endpoints that are served to the applications by the OOP. Application deployment, edge cloud zone retrieval, location retrieval, and federation management. Let's try a quick edge zone retrieval using CAMARA to validate that the Open Operator platform communicates with its application deployment zones. As you can see, as you could see, we got the deployment zones from the interaction. Now let's go back to the CAMARA location API. Excuse me, I forgot to mention that to be able to run the OP, some prerequisites are required. We need to have Docker installed, kind, kubectl, and Helm. Now, moving on to CAMARA device location. So, CAMARA device location API provides the location of a mobile device as detected by the mobile network operator. The request can specify the maximum acceptable age of the location data, and the response delivers the detected location represented either as a circle or a polygon. This has many use cases, such as fraud prevention, service personalization for location-based marketing, emergency services, delivery services, or asset tracking. Now we'll take a look at the integration. So we assume that we already have cloned, as Gerald showed, the open exposure NEF to our machine. Given that, yes, so what we do now is we check some of the configuration files. Specifically, since we want to also integrate quality of service, we will check that out first. To enable the QoD functionality with OpenOP, we need to check the QoS configuration. The OpenOP OAI adapter expects specific QoS profile names. Specifically, we need to configure for QoSE, QoSS, QoSM, and QoSL. These names need to match what the service supports, otherwise later QoS requests will fail. If we change this while the stack is running, we must also redeploy it so the changes take effect. Next up, we start the core simulator. By visiting the core simulator's Grafana dashboard or by checking its logs, we can see the attached GUI's IPs, which we can later use for targeted QoS or location retrieval. At this point, OpenOP is running, but the SRM is not yet connected to the NEF. OpenOP is running inside the kind Kubernetes cluster, while the NEF stack is running as Docker Compose containers, which means that they cannot communicate. So we connect the ingress container to the kind Docker network. This gives the ingress container an IP address that is reachable from the pods running inside the kind cluster. After connecting the container, we inspect its Docker networks and get the IP address on the kind network. This is the address that the SRM must use to connect. Then we go back to the OpenOP Helm values file. Here we will need to set the configuration. So we set the network adapter name to OAI, the network adapter base URL to the NEF ingress IP on the kind network that we just got, including the port and the HTTP scheme. We must also set SCS as ID, but currently it can be anything. After updating the values file, we run Helm upgrade. This applies the new SRM configuration to the running OpenOP deployment. Since the Kubernetes token is injected through Helm, it must be passed again during the upgrade. At this point, the integration is wired end-to-end. So let's try a CAMARA location retrieval API call on one of the known UE IPs. So we got the reply that shows us the location of the device plus null century radius. The request flow is as follows. The API client sends a CAMARA API request to the OEG. The OEG forwards a request to the SRM. The SRM chooses the OAI network adapter and builds a southbound request. That request goes to the NEF ingress container over the kind Docker network, and the ingress routes it to the correct 3GPP NEF service. And then the NEF service communicates with the core simulator. Here we can see the code reply. Let's take a look at a realistic use case for location retrieval in an airport. This is an application that uses the CAMARA APIs through OpenOP's northbound interface. Airports operate hundreds of service vehicles simultaneously, like baggage carts, fuel trucks, and shuttle buses. Location retrieval could assist with the restricted area monitoring, emergency response, fuel refill, and logistics. This was the demo. Thank you very much. I will pass you over to Konstantinos Karitsias.
Thank you, Tasso. My name is Kostas Karitsias, and I'm a senior R&D engineer at Telecom. I'm also the module leader of AI Squared module. We are going to delve into more details now about OpenOP and the jetting operations, which are being enabled by MCP, and the relevant CAMARA integration. So you may be already aware of the terminology about model context protocol, which is basically a standardized way for the LLMs to interact with external data sources, APIs, and software systems in general. And CAMARA MCP standardization has started already in September 2025. So far, 15 MCP tools have been mapped from 9 CAMARA APIs, and also 7 MCP resources for state management and 8 MCP prompts for common operations have also been defined. A lot of work is underway to integrate CAMARA API calls to MCP ecosystem as well. Now, as you can see on the right-hand side of your screen, this is a white paper that was published by CAMARA project. It was published in January 2026, and it is entitled Bridging AI Systems and Networks Infrastructure through MCP. And it talks about how to build network-aware intelligent applications. So, as you understand, there is a lot of momentum in this area, and that's why we focus our efforts on this direction. Now, on the left-hand side, you can see the CAMARA Quality on Demand API endpoints. This will serve as a case study for our future demos. At the bottom, you can see the OpenAPI specification for Quality on Demand version 1.1.0. And on top of it, you can also see the CAMARA API to MCP tool mapping for Quality on Demand. The API endpoints, the MCP tool naming conventions, what is the purpose of its MCP tool, as well as the input and output data. Now, I will walk you through the MCP submodule architecture and the tech stack. As you can see in the figure, at the bottom, it's the 5G core. On top of it, we have the OpenOP software stack of Release 0, which is composed of the OpenOP Open Exposure Gateway, the SRM, the Federation Manager, and the transformation functions. And on top of it, we have the first AI Squared module, which is the MCP enablement module. That was built using the fast MCP SDK, which is the most well-known Python SDK for building MCP servers. We conform to CAMARA specifications, performing strict data schema validations for tools that have already been standardized. But for non-standardized operations, custom tools have also been defined. And for the debugging of the MCP server, we leveraged again a well-known tool, which is the MCP inspector. And now, in order to showcase a demo, there are several AI applications. We decided to go with OpenWebUI. Again, a well-known tool, which is an extensible, feature-rich, and user-friendly self-hosted AI platform. It provides the users the capability to connect with external MCP servers, provides a really intuitive UI that the user can perform queries in natural language, and also offers the capability to connect with third-party LLM models for experimentation. And let me walk you through really quickly the first demo. So as you can see right now, on the right-hand side, this is the UI of OpenWebUI. The LLM that we're going to use is the GPT-OSS 20 billion from OpenAI. And the query that we're going to ask basically is to create a call-on-demand session for specific device IP, application server, quality of service profile with quality of service E premium service profile and duration of 100 seconds. As you can see, the MCP server has already been registered via the OpenWebUI. And now we're going to push the button and send the relevant message. As you can see, the query was executed correctly, and we're getting back the session ID. And this is also the JSON data that are being retrieved from the MCP server back to the OpenWebUI. Now, on the left-hand side, you can also see the EURECOM Grafana dashboard that shows data that come from the NEF. And as you can see from the deviation of the time series, this is the UE that gets the premium quality of service profile. So the call on demand session has been instantiated correctly. And at the same time, we will ask, the user will ask to delete the call on demand session. As you can see, the session was deleted correctly. And again, if you check the visualization, the session ended correctly. So that was the first demo. And we will move forward to the second slide, which is going to describe about the agent submodule architecture. This is the second part of the AI2 module. And what was the goal? Let me explain you the rationale why we did so. So in principle, we wanted to reduce the dependency on third-party platforms by delivering natural language interface using a lightweight open agent framework. In this way, we wanted to avoid the licensing risks because tools such as OpenWebUI do not have a concrete open source license. So it's really difficult to modify them and redistribute them. And another thing is that a lot of these tools come feature bloated, which means that they provide other capabilities such as retrieval augmented generation and other kinds of operations that are out of scope, at least for OpenOP's release 1. And now I'm going to discuss about the key components that we decided for release 1 to put, let's say, into the agent. So we started with a bare minimum of the components, so it could be usable. The first one is the LLM interface, which, as its name suggests, provides interface towards the LLM. And this provides basically the planning, the reasoning capabilities, and the structured outputs back to the user. We also have prompt templates that govern the agent behavior using specific instructions. And the next one is the MCP client, which basically is the way for the agent to execute the capabilities and the tools that are being exposed via the MCP server. And now, with regard to the northbound APIs, we implemented two. The first one is the REST API that provides the traditional CRUD operations and debugging endpoints. And the second one is the server-side events, which provides real-time streaming of agent responses by chunking the responses into small chunks back to the user. And let me go through the tech stack. So For the agentic orchestration layer, so to speak, we used the MCP use library. This is the open source library that connects LLMs to MCP servers and lets you build custom AI agents. It also supports integration with any large language model that is compatible with LangChain, which is literally any LLM provider. And for the backend, we used Quart, which is an asynchronous Python web framework that enables scalable input-output operations and real-time interactions with AI agents. And let me go really quickly through the end-to-end sequence diagram, what is happening when the user sends the query. So the user sends the query towards the agent is being initialized, and then we're getting into the agentic loop. The first step is the MCP session initialization and tool discovery. Then the request, together with relevant prompt and context, is being fed to the LLM. And then the LLM leverages its reasoning capabilities, processes, and decides which is the next action. In case that the action is a tool call, then this result is being fed back to the agent, and the agent executes this tool via the MCP client. And the MCP server, on its turn, execute the API call towards the OpenOP Open Exposure Gateway. And in the opposite direction, you can see that we're getting back the API response. This is being turned into a tool result from the MCP server towards the MCP client. And then all the result, together with the updated context, is being fed back to the LLM. And this loop continues until n number of tools result are finished. And finally, when this loop finishes, the final result is being fed back to the user. And let me go through really quickly the second demo. So as you can see, the query that we're going to send to the agent is more or less the same that we used with OpenWeb UI. Let me run the video. So yeah, we create a call to demand session again for the same IP address, application server, the same quality of service profile, and the same duration. As you can see, this is the result. We're getting back the session ID as well as recommendations for future steps. Again, on the left-hand side, you can also see the deviation in terms of traffic throughput of the specific UE, and we will also see the termination of the relevant session ID. So everything went smoothly and correctly. And we have our own solution, which is more flexible and a lot more lightweight and can be easily integrated with our own user interface. Okay, so thank you all. That's all from my side, and I give the floor to my colleague Sergio from ITUCAT.
Thank you, Kostas. Okay, so I'm Sergio. I'm an engineer at ITUCAT, and today I will do a deep dive into the Federation Manager. So before getting started, just to remind what Dimitri started saying, what's the motivation and scope about the Federation Manager. So the telco infrastructures must evolve toward interoperable, federated environments to support the next generation of mobile services. So currently, the current operator infrastructure is heterogeneous and often is vendor dependent. So we need a robust east-west-bound interface because it's essential for seamless inter-operator federation and to enable global monetization. So if we take a look at the architecture, the Federation Manager sits somewhere here, and what it does, it enables the capability to share resources between operators, okay? And these resources are basically compute resources and network resources. So the Federation Manager, as I was saying, allows to securely share the resources, compute resources and network capabilities between operator platforms that have established a federation. Okay, this federation, it's performed over the east-west-bound interface, which basically is defined by the GSMA OPG 04. Currently, in the release 1, we support the version 6 of the specification. So the Federation Manager, it serves as a critical handshake component that establishes the trust and the protocol alignment between these two administrative domains. So the Federation Manager has 5 core operations. Okay, so the first one is the establishment of the federation. So imagine that I'm an operator and I want to establish a federation with another one. So I send this federation establishment request. The other operator will acknowledge me, and then he will send me the list of the zones that I am able to subscribe and use. Okay, so once I receive these zones, what I can do is that I can subscribe to that zone. Okay, I can subscribe to either one or more zones. So at this point, the federation is already established. So and I have the operator zone as my availability zone. So now what I can do is I can share artifacts. I can onboard applications, and we can also manage the lifecycle of the applications. Okay, and in fact, all these 3 operations it's what we will see in detail in a few minutes in the demo. Okay, so the first part of the demo will show the local operator deployment flow. And as it was explained before, here the operator will deploy an application, but it will deploy in the local domain, okay, inside his own operator domain. So the request will go through the OAG, which exposes the CAMARA Edge Application Management API. Then it will go through the SRM. Then in turn, it will go through the transformation function SDK, Kubernetes adapter, and then finally it will deploy in the Edge Cloud platform, okay, which in this case, it's a Kubernetes cluster. And I want to stop here because this Kubernetes adapter is some new addition of this release. So basically, it's an adapter that it works in any, so it uses vanilla Kubernetes mechanism, so it will work in any Kubernetes distribution. So you can actually try it out. And the next part of the demo, it will show how using the same endpoint, it will deploy the same application, but instead of going through the SRM in the local domain, it will go through the Federation Manager because it will be deployed in the federated domain. Okay, so let's jump into the demo. Okay. So here what we have, it's on the left, we have the operator platform. So we have 2 deployments at the I2CAT premises, and we also have 2 Kubernetes clusters, okay, 1 for each operator, as I showed before. So what we do now is that we will check the OEG for each operator platform, and we will check that initially the available zones are only the local ones. Okay, so we have this operator, which we call the local operator, just for clarity's sake of the demo. And then this one will be the remote operator, okay, just for clarity. We will perform all the operations with the local operator, so we don't need the other one. So now the first thing that we will do is that we will onboard the application. So what we will do is that we will onboard a simple Nginx server, and we will onboard it into the operator platform. So once it succeeds, it returns us the application ID. And now using this application ID and also using the ID of the Edge Cloud zone, we can deploy the application. So we will do that in a second. This is the application ID, and this is the Edge Cloud zone ID of the local zone. And right now, the application is deployed in the local cluster. Okay, just to prove it, 5 seconds ago, it's just like an Nginx server running. So now we will perform the same, but instead of the local operator, we will do it in the remote. Okay, so as I explained before, first thing we need to do is to establish the federation. So let's first invoke the partner endpoint, and that will return us the federation context ID. This is an ID to identify the federation, and it will return as well an array of available zones that we can use, okay? In this demo, there is only one zone that we can use. So yeah, we will use that one. So after that, what we will do is that we will subscribe to that zone. So we use the federation ID provided by the remote operator, and we use that availability zone. Okay, now we are subscribed to that zone, so we are able basically to use that availability zone from the other operator. Just to prove it now, if we check the zones that we have available, we can see that we also have the remote operator zone. Okay, so at this moment, we can operate this zone as if it was in our domain. And also I want to show you that this is not bidirectional. Okay, so federation, it occurs in one way only. So the other operator still only has one zone. So what we will do now is that we will deploy the same application that we onboarded before, but we will deploy it in the remote zone. So we just for that we just need to change the ID, the federation, the Edge Cloud Zone ID, and now we can see that the application has been deployed at the partner OP. Just to show you, if we check the Kubernetes cluster, we can see that there is this application deployed just 9 seconds ago. So okay, so that was basically it. Just some closing remarks. So we saw that the Federation Manager enables multi-operator federation as well as the application lifecycle management. The transformation functions SDK, it translated the CAMARA Edge Cloud Application Management API calls into concrete southbound interface actions via the pluggable adapters. In that case, we use the Kubernetes adapter. The CAMARA APIs are nice because they provide standardized northbound interface. And then the OOP wraps these functionalities to enable interoperable, scalable, and vendor-agnostic federated deployments. So that was it. I hope you liked it, and I think now we have some time for questions.
Yes, so let's go back to some human faces. So thank you for that. We have a few questions to go through, and we have time for that. That's also very good. So first question. So we are witnessing growing interest in the AI and data dimensions of telco cloud environment regarding their internal operation for things like automation, user centricity, and customer experience. Is OpenOP addressing this area?
Okay, thanks for the interesting question, Natalie. I'm gonna take it. So my response is yes, absolutely. And this is actually becoming one of the key strategic directions of OpenOP. Even from the beginning, OpenOP was not designed only as a telco cloud federation platform, but instead as an open and programmable platform spanning telecom, cloud, edge, AI, and data domains. So the OpenOP initiative already includes AI native interfaces, federated orchestration capabilities, as well as standardized exposure APIs, aligned with CAMARA, GSMA, federation principles, and so on. But what is particularly important now is that OpenOP is evolving into something beyond infrastructure federation and towards data and AI federation. And this is exactly the motivation behind the newly introduced Data Lab module, the OpenOP Data Lab MDG, which brings DataOps and AI-oriented capabilities into the platform. In this way, enabling orchestration of data pipelines and analytics workflows, exposure of AI and data services as reusable platform capabilities, lifecycle support for AI ML pipelines, as well as trusted sharing of data and models across federated operator and testbed environments. So a very important aspect there is that the Data Lab adopts a data space oriented approach from the European data spaces concept. So through data space connectors and policy-governed exchange mechanism, OpenOP can support interoperable and sovereign sharing of data sets, models, and data ops and analytics assets across multiple domains and organizations. And this is highly aligned with current European directions around data spaces, AI factories, as well as trustworthy AI ecosystems. So if we look at use cases like AI-driven network automation or intent-based operations or customer experience optimization, cross-domain analytics, and federated AI experimentation across operators and testbeds, OpenOP is increasingly positioning itself as the open integration layer where these capabilities can interoperate in a standardized and reusable way. And this is also exactly where projects such as Sunrise 6G, which is the birthplace of OpenOP, but also 6G DALI, which is the project contributing the data lab module innovations, are becoming very relevant because they are already contributing AI, MLOps, and data ops innovations that fit directly into the OpenOP ecosystem and roadmap.
Okay, so we have to answer a bit faster for the next ones because we're closing in 10 minutes. So how do you see AI capabilities fitting into OpenOP in future releases?
Yeah, hi Natalie. I will take this forward. So first thing first, for release 1, the main missing part from AI squared module was basically the agent memory. This is something that we're going to deliver as part of release 2. Now, the agent memory is a quite broad topic. There are a lot of subcategories: short-term memory, long-term memory, and a lot of implementations. For release 2, we will focus on the short-term memory and the efficient management of the LLM context. And currently, we have discussions on this topic. Okay, that's it for this action point. Another action point that I can think of is the integration with other LLM providers, a lot of LLM providers, basically. So a user from the UI can select the LLM provider that would like to connect to, and the operation will be more or less seamless. And another key topic is also the observability, and more specifically, it's the tracing of the agent. So we would like to have more granular information on the latency of its tool invocation and the steps of the agentic loop, as well as other parts such as the tokens that are being used as input and output. Because if you may be already familiar, more tokens in terms of open source LLMs means a lot more latency, and in case of proprietary LLMs means more cost. So we're going to introduce such tools into the OpenOP ecosystem. And we have also discussions for other features as well, but okay, stay tuned to the OpenOP social media and you will see them there.
Okay, thanks, Kostas. Quick question. How could a new vendor or project integrate its solution with OpenOP?
Yes, I could take that. There are two ways. On the northbound integration level, let's say, someone could tap into the CAMARA APIs that we provide in the Open Exposure Gateway. So this is how the integration happens. And then every CAMARA request is validated, is going to be authenticated and propagated internally in the correct components of our platform. Now we are also looking into expanding these families of APIs that we expose on the Open Exposure Gateway by potentially bringing in Team Forum APIs or other families that we think that are relevant in the ecosystem. But also, as Kostas mentioned, we are really looking into the AI aspect and capabilities of our platform and potentially also enable agent-to-agent interface if someone would like to integrate his agent with OpenOP. But this is still in the roadmap. We haven't started the effort. Maybe I can take a few more minutes and expand how someone could integrate also on the southbound. And this is quite easy using our TFA SDK. So if there's a vendor or an operator who has his external system on the southbound or his infrastructure, Someone could just take our TF-SDK and write code there, write a translation function from the service resource manager abstraction level towards the specifics of what lies underneath, whether this is a network component or a cloud platform or an orchestrator or anything. So yeah, hope this answers the question.
Thanks. So next question is, what is the benefit of exposing location retrieval through CAMARA APIs instead of letting applications integrate directly with the NEF? NEF. I don't know who wants to take that one.
Hey, I take that one. So CAMARA gives applications a standardized developer-friendly node-bound API in contrast with a normal NEF. The application does not need to understand the operator's internal NEF deployment, the southbound details, or the core network specifics. So the OpenOP, it acts as an abstraction and orchestration layer between application-facing APIs and the telecom network capabilities.
Okay, we have 4 minutes left. What role does Helm play here beyond just installing the platform?
I'll answer that one as well. So Helm gives a repeatable way to configure and deploy the Open Operator platform. It lets us define the service ports, the environmental variables, and the adapter settings. So instead of just doing the deployment, it also helps us manage it further through Helm upgrade, for example.
I'll take one last question. For the NB APIs, have you thought of vetting APIs and/or processes for verification of the developer party? And there's some background on the last GSMA RCS meeting. There was a discussion on the vetting improvements. Anybody who wants to volunteer for that one? Because I cannot answer that.
Yeah, we don't have really a process on that, but what we can say is that we have already a task force running around testing of the platform led by Orange Romania. And the goal there is to verify the different CAMARA APIs and make sure that our platform is compliant to the different specifications. So yeah, I don't know, Vasilis, whether we would like to expand more.
Really, Dimitris, I think you cover. We have a very interesting and vivid, let's say, and fertile task force that just started about verification and validation of northbound APIs. This is essentially a hub for developing and co-creating different assets that can be used in a reusable manner by different communities in order, to test whether or not different network facilities or test beds are indeed compliant with whatever standards, especially on the northbound, are promising towards developers who are, from the cloud domain and the cloud APIs era a bit, I would say, spoiled on that, and they would very much like to have a consistent and homogeneous experience across different domains. So this is the main objective and purpose of this task force. It just started some weeks ago, actually. We're very happy that Orange Romania is taking the lead, and we have important participation by many stakeholders, members and participants of OpenOP, and lately also from GSMA. So again,
I need to close. We're gonna get cut off. So sorry for that, but many interesting questions. This is being recorded. This will be available later on today, the recording and the PDF of the presentations. Thank you all for the hard work in putting this together. Thank you all for